Welcome to topic 4 of data science, and this topic is big data technologies, specifically Hadoop and NoSQL. So Hadoop, what is Hadoop? Hadoop's a framework, all right, that allows for distributed processing of large data sets across clusters of computers using simple programming models. So let's just say we have a very large CSV file, and we need to access that to analyze it. Let's say it's a big list of our customers, all their order details, their addresses, their phone numbers, their email addresses, their order history. Now, that's all well and good. Now, but let's say that CSV file had 1,000,000 lines in it, or let's say it had 1,000,000,000 lines in it, or let's say we had 1,000,000 of those 1,000,000-line CSV files. Would we still just be able to store that on a single server? Likely no. Okay, so at that point, we need to look at something that we would call distributed computing, okay? Distributed systems, which means that we can spread that data across multiple systems, but still access it as if it's a single entity. And Hadoop is one of the technologies in what's called big data that facilitates that. So Hadoop was originally created by Yahoo. In 2008, it was released as an open source project, and it was taken over by Apache, okay, the Apache Foundation, who also are in charge of the Apache web server that we've used. Now, I've added a link that should be available later. This is an old video from maybe 2012, 360p, kind of 4:3 video, but it's an American chap, and he goes into a little bit more detail than I feel we need to today. So if you're interested later on, you can have a little look through that. Now, the Apache Software Foundation maintain a list of companies using Hadoop, and they're companies you might suspect like Facebook, LinkedIn, Twitter, Spotify, and obviously Yahoo, because Yahoo invented it. So the first example to talk about today is a company called Flickr. Now, a few years ago, Flickr was quite popular. I'm not sure if it's still popular, although I'm sure it still is. Now, when you upload a photograph to Facebook or to Instagram, okay, that photograph gets compressed because it's likely that someone's going to look at it on a phone. And if they're going to look at it on a phone, there's no need for it to be 4K resolution, okay? Because it's so small that it's difficult to tell anyway. There's no need for the picture to be huge. The other reason is, if the picture is giant resolution, 2000 pixels wide, it's going to be much bigger in size. So photographs, when they're uploaded to sites like Facebook and Instagram, get compressed. Now, I think Flickr's kind of selling point was that they didn't, they kept the image in high quality, okay? So it was favored more by photographers. Now, at one point, okay, statistic I found, not sure how true this is, it had 90 million users and 8 billion pictures, okay? And these were high quality images. So because of this, they took up a lot of storage space. So Yahoo at one point had the largest Hadoop file storage and processing cluster in the world, with 32,000 servers and 600 petabytes of storage. Okay, so that's quite a lot. Okay, 1,000 terabytes. So if you imagine 1,001 terabyte, 1,024 1 terabyte USB hard drives all stacked up in your house, then you imagine 600 of those 1,000. Okay, so imagine 1,000 USB terabyte hard drives stacked up to the roof in your house, and then imagine that times 600, and then imagine that inside 32,000 Linux servers in racks inside a big data center somewhere, and then imagine the noise of the fans of all those machines and the people having to walk up and down and unscrew bits and swap hard drives. So a giant operation, absolutely massive. Okay, so how, when you go to the Flickr website, can you click on a photo and it loads? Where's that photo stored? It's stored on one of these different servers, likely to be a Red Hat Linux server or possibly a Debian server. Probably, I'd have to look into this, but likely probably 75% in favor of Red Hat and maybe 20%, 25% in favor of Debian. Okay, so there's a Flickr example. Now, Hadoop, the Hadoop architecture has 4 main parts to it. Okay, 3 of them are very simple. Okay, one of them is just called Hadoop Common, and that's just some tools. This one is a file system, HDFS. Okay, Hadoop Distributed File System. That allows you to distribute files across different computers. Then there's Yarn, which is a job scheduling process that it lets you distribute processes across multiple different processors. And then we have the MapReduce algorithm, okay, and that performs 2 tasks: mapping data and then reducing data. Okay, so performs mathematical operations, reducing, counting the number of customers over the age of 21 on the map job output. Okay, so mapping and reducing, Hadoop MapReduce. Now, a little bit more detail about these. HDFS is just like any other file system we might have looked at. We might have looked at NTFS file systems, FAT32 file systems. DFS is a distributed file system, and putting H at the beginning just means Hadoop. Okay, and this is just a storage option that lets you store files across multiple computers. Okay, so that's the Hadoop file system. HBASE is a open source distributed non-relational database. Okay, so there's a little logo down here for HBASE. It's like this little whale. Okay, have you ever seen that whale, Apache HBASE? And it provides big table capabilities. Okay, it lets you store very large amounts of data. So we have in the past used MariaDB, which was a relational database. HBASE is a non-relational database designed for very big data. Okay, so some more tools associated with Hadoop. Ambari is this front end here, graphical front end. So, you know, you have all these tools down here. Look, HDFS, he's got a little green tick beside it. MapReduce has a green tick. What else have we got? HBASE has a green tick. Okay, so these are all tools associated with Hadoop, and this is like a control panel, a front end, all right, that tells you, you know, what state the memory usage, the disk usage is in the Hadoop cluster. This is like a front end. Also lets you, has some wizards, set up wizards and things. And then Mahout is a technology for doing machine learning algorithms on the data that you have set up. So Ambari is a front end, and Mahout is a technology for data science algorithms inside Hadoop. Okay, Lucene is a text search engine. Okay, so it's designed for searching and indexing through data. Okay, Lucene it's called. It's got this funny logo here. This is a little example. Here's you sitting at your desk searching, okay, and Lucene can analyze a lot of data and return values to you. So here's a little summary of those components I just talked about. HDFS is the file system. MapReduce is an algorithm. HBASE is a database. Ambari is a front end. And then Mahout and Lucene are different technologies within a Hadoop cluster. Mahout's for algorithms and Lucene is a text search. So those are the kind of main components in the Hadoop architecture. And here I've put a kind of, this is a couple of graphics I found to try and illustrate what this architecture looks like. So if you imagine we have some disks down here running the Hadoop file system. Then we have Yarn above it, resource management. And then we have Ambari, which is like the front end over all of this stuff. Okay, and here's all these different technologies in here. Okay, Apache Spark, Lucene Search, HBASE. And there are an awful lot of these. There's another one called Zookeeper. There's Pig, which is for scripting, Mahout that I just talked about. So we don't need to know exactly how all of these different things work. And in fact, places I've worked, each of these was dealt with by a whole team. Okay, so there'll be a whole database team dealing with databases, and there'd be another whole team dealing with like search technologies, and there'd be another whole systems team dealing with disks and stuff and managing the cluster. So it's very unlikely that someone would be an expert in all of this, although I'm sure there are some people out there. Now, this is a similar image, but we don't have the logos on it. Okay, so down the bottom, we have the file system, then we have some processing above it, then we have these tools that can run on top of that. Okay, and this is kind of illustrating that the database can kind of go between the tools and the processing. All right, there's Zookeeper over there as another technology. So I used to work in a company, and there were a global team that dealt with Zookeeper. Okay, so let's say the company had maybe 15,000 employees, and the Zookeeper team maybe had like 30 or 40 people in it globally. So 5 people in Edinburgh, 5 people in India, 5 people in Singapore, 10 people in America, 10 people in New York. Okay, and they were always arguing about Zookeeper and stuff to do with it. Okay, so so then there would be another team of similar size, maybe a bit bigger, that were to do with databases, and they wouldn't just deal with HBASE. There's another database called Cassandra, which is a NoSQL database as well, and they would deal with managing databases and how data was stored and shaped in those databases. So no one was sitting managing this whole thing themselves. Okay, that would just not be possible. It's too much for one person to do, unless you have it set up in your house and you have nothing else to do. Okay, so we can actually interact with a Hadoop cluster using some of the programming languages. So there's a library for R called Revolution R Enterprise that lets us go in and run code on Hadoop clusters. Python has some libraries, Hadoopy and PyDoop, and there's a platform called HBASE, okay, that allow data scientists to analyze data inside a Hadoop store. Apache have their own thing called Apache Hive, and then there's this thing here called Tableau. Now, Tableau say that they're the leading provider of data analytics software. Tableau is good for making graphs and things, but the downside to Tableau is that it's, now I think it's proprietary. I think you have to buy a license for it. And also it only runs on Windows. Okay, so I'm not entirely sure. Let me just check. Okay, Tableau. So let's say we wanted to get Tableau. We could get a free trial. Okay, but I'm pretty sure we're changing the way you think about data. So let's say we want to buy it now, right? Let's wait and see how much you want. Okay, so I was thinking about it, buy.tableau.com. So here we go. So for a creator license, you're looking at $70 a month. And for an explorer, and that's for every deployment. So let's say you wanted to have a global deployment, you're probably looking at maybe 16 servers. You're looking at, $14,000 a year plus, $14,000 plus tax. Okay, so quite a lot of money, isn't it? And that's to connect your data. What about just to access? So if you want, and let's say you had another, 40 people that just want to see dashboards. Okay, that would cost you another $7,000. Okay, now let's see what Tableau looks like. If we can, be good if they showed us like you know, visualization gallery. This is good. You can see what it can do. Okay, so look, there you go. You can do these kind of things, right? Now, let's have a look at this. This is probably an interesting one. Okay, so Tableau would let you build a dashboard that looked a bit like that. Okay, I'm guessing we can we slide this? Yes, we can. Look. Okay, so this is still stuff that you can do with R and with Python, but I think Tableau it's just designed to do this. Now, another issue as well is that Tableau, as far as I know, only runs on Windows. So if you were working in a company that wanted to use Tableau, you would have to have it running on Windows Server. Okay, you'd have to install, and it would have to run on like load balanced Windows Server. So they would have to have some kind of access via the Active Directory to the service. I suppose you could run it as a web service, but again, if you're going to introduce Windows servers, then you're going to have the Active Directory running, which means you're going to have to do Windows Update. You're going to have to reboot the Windows servers. You might have to have PowerShell scripts. Then you've got security issues, the Windows firewall, the network firewall, ports to open. So quite a lot to consider. So I would definitely try and push people more in the direction of using R for obvious reasons, because I don't really like Windows. But there we go. So that's the first topic. NoSQL is the next topic. I've just put this definition here. The main focus of data science is the extraction of knowledge from data so that actions can be taken based on insights. So the next technology is NoSQL. Now, before we look at NoSQL, let's look at SQL. So SQL stands for Structured Query Language, and we've already used this when we did managing web servers. Okay, managing a web server last year. We created a table, create table shop, into shop, put item, and then select star from table. Okay, so whenever you see this SQL syntax like this, okay, and you see tables, okay, what you're talking about is a relational database, okay, or a relational database management system. So MariaDB, MySQL, PostgreSQL, Sysbase, these are all relational databases, okay, or relational database management systems. And inside those, okay, these are like servers, and on these servers you can have databases, and inside those databases you can have tables, and inside those tables you can think of those as like giant Excel sheets. You can have rows and columns of data, and then each table has a primary key, and we can select something from one table and also something from some other table as well, and pull them out. So that's SQL in a relational database. So if that's a relational database, what's a NoSQL database? So NoSQL is actually a wide variety of technologies. In fact, there are probably more NoSQL databases than there are SQL databases. So developers that are working with applications that create massive volumes of data, okay, a relational database isn't really designed to cope with that. Okay, putting things into tables and things. When you have a giant amount of data, a NoSQL database is actually faster. Okay, so what are the benefits? It's more scalable and it gives faster performance. So down here, we have a relational database management system, which has different tables, and those tables have relations between them, okay? Primary keys, and select star from table over here. Now, over here, this is MongoDB, which is short for a humongous database, okay? And it stores data in this JSON-like format. It actually stores data in a format called BSON, which is binary object notation, but it looks like JSON for our understanding. Now, this is much faster for very large data than having it all in tables. So this will let you have a geographically distributed scale-out architecture. Instead of having a single MariaDB, a single MySQL database that has replication in 2 locations, the NoSQL database is designed to have all the data distributed and to grow very, very quickly. So no tables. Okay. So a NoSQL database, if a node fails, so if a server goes down, the other databases can replicate. Okay, they can rebuild this node. So say a disk fails here, we can contact someone in our data center in Asia or in America, and we can say, you know, we've got a disk failure alert on our control panel here. Can we have this disk swapped? We put a new disk in here, and then these would replicate back in here. So this is built in, this replication technology. So here's some examples of some NoSQL databases, different types. Very simple one, a key value database is just keys and values. Okay, a graph database. Now we set up a graph in lab 3. When you think of a graph, you think of like a bar chart or a line chart, but this kind of node and link structure is also called a graph. Okay, so there's a thing called a graph database. These are used in social networks. Then we have a column family database and a document database. Now I've got experience with document databases. You just think of these as like JSON files full of data. Now, some examples over here of names of these. They've all got silly names. So a key value database, there's one called REAC. Document database, which I have used before. MongoDB is probably the most common one, and there's CouchDB as well. Then a big table database, right? HBASE that we already talked about is one, and I already mentioned Cassandra. So these are called wide column stores. Okay, they can store lots and lots of data. And then there's a graph-based, not something I've ever set up myself. So there's one called Neo4j, Infinite Graph. Okay, so those are just some examples of some different technologies. So in more detail, a document database, there's key value pairs in nested document files. Okay, graph stores, and there's Amazon Neptune as a graph store database, and they store information about networks of data, like social connections. Key value store is the simplest one. We just have keys and values in a big giant file. All right, and then a wide column store like HBASE is designed for doing queries over huge data sets. So that's the end of the theory topic. Now, someone asked in the last class, you know, when would you use a NoSQL database over an SQL database? And the answer is, I can't really give you a direct answer on that, but let's think of a scenario, okay? If you came to me and you said, I've got a small business and I run a car mechanic garage where people come to get their car fixed. We have 2 locations, and when a customer comes in, our database, we generate them a customer ID, we take their name, their phone number, their car registration number. Then when we put the registration number in, there's an API that automatically looks up their car model, make, color, and populates that. We've got that working in the background. That could be some Python script that does that, some web service that does that. Then we have, you know, what they've had done to their car, how much they paid, what part numbers and things. And then we have another database, and it has like all the different car parts that we stock and how much each one is. So if a customer comes in and says, hi, I'm looking for a new tire for so-and-so car, I can type in, I could say, what's your registration number? Type it in, it'll say, okay, that's a Volkswagen Golf, or that's a Toyota Corolla or a Honda. And what size of tires have you got? They say, I don't know. But the best thing to do is go out, look at the customer's tires at the side, 17565R14, type that in, and then we can say, okay, we can do you a budget tire for this. Right. Hopefully I've painted enough of a picture of a scenario for you. I've gone into far too much detail there. For me, that would be an SQL database. We'd have tables like the customer table, the parts table, the customer details table, and we're not really growing that data. It's not really big data, is it? Let's say we fix 10 cars a day, and one of them is a repeat customer. So at the most, we're going to be adding, say 50 records a week. And if you think about this is inside a text file on a server, it's not really significant adding that amount of data. Okay, maybe after a year we might be using a couple of gig of storage. Now, let's say I told you that we were scraping web data from social media posts using some kind of an algorithm. We were pulling in Twitter posts about news articles and analyzing them, and we were scraping in 50 gig of data an hour. That would probably be a case for a NoSQL database. Where the other thing as well is, in the NoSQL, we're not going to have set tables. Okay, so we're not going to have, we don't have things like customer ID. These can change all the time. News stories change, so there's not really a relation between. So that would be more of a case of a NoSQL database when we have very large data. Now, put a link here. There's a very, very good course, okay? And it's a little bit beyond the scope of what we're doing today, but it's called, there's this website called university.mongodb.com, MongoDB University. Okay, now, oh, look, University Forum will be unavailable. Okay, that's good. At least the university won't be unavailable. Now, let's go back. There's a course called MongoDB Basics. It's 3 modules, or it was when I did it. And, they've got a new instructor, Yulia. Okay, used to be a man called Shannon. Okay, so you learn the fundamentals in this course, and it doesn't cost anything. So if you think you have a spare, I don't know if it would take you a full 8.5 hours. Let's say you could maybe get through it in 6 if you were paying attention, taking notes. So you can do this, and this would give you a certificate, and this would explain how MongoDB works. And there's videos and stuff, and this shows you how to do. They have their own query language and stuff. So if you wanted to learn more about SQL, NoSQL databases, this would be the place to start. Okay. Prerequisites for it: a basic knowledge of programming, such as the command line, functions, variables, and booleans. So I think everyone in this class will have that. Okay. 6 chapters. There used to only be 3 chapters. So they've added to it. And all you need is a web browser, really. And you get a final grade, and you have to get 65% to get a certificate at the end. So there you go. And then there's other courses they do. All their courses are free, but that would be the one I would recommend if you wanted to learn more about NoSQL databases. That would be where I would start. I did it, and it was very interesting, actually. So let me just stop this recording now, and we can talk about let's just talk about the work for today. So this week, okay, there's no more ePortfolio, all right, and we're about to move on to R. We're about to move on to Python after this. So there's a short coursework to complete this week. Now, we already covered this in week 2, topic 5. So what we have to do this week is download this document. Okay, it's a docx file. For those of you that like docx files, for all you docx fans out there. So it'll probably open horribly on my LibreOffice, but who cares? So things like on LibreOffice, things like this don't render properly, all right, and page numbers as well. But if you were to open this in Google Drive or Microsoft Word, it would probably look a bit better. Right. So the instructions are download this CSV file from the Moodle page. Okay, the CSV file is here, IMF inflation rate, consumer price percentage. So let me download that and we'll show you what that looks like. I'll open it in my LibreOffice Calc. Okay, it's opening, here it is, click OK, move it over here. So it looks a bit like, well, we'll talk a bit more. Okay, so I want you to edit this document file directly and then upload it to the Moodle once you're complete. Okay, now it involves a little bit of research. Okay, so for example, question 1 is, what is a CPI? Okay, and how are these an indicator of changes in living costs? So you're going to need to, this assessment is about the CPI, the Consumer Price Index. So you're going to need to do a bit of research and look up. You don't need to do any programming for this question. Okay, give some examples of items in the CPI. Why might the CPI differ in 2 countries? Okay, then some more research here, and we can see another example of LibreOffice not being able to render page numbers either. Probably something I have to turn on irritatingly. So this question, you just need to do a bit of research as well. Edit this document, answer here. Okay, then in part 3, we have to download the data set and then import it into R. And for each question, okay, you have to put the R code and write a little bit and maybe add a screenshot. Okay, so question 1, download the data set and import into R, provide a summary of the data set. Okay, so how would you do that with R? Put a screenshot here, 1 mark, all right. How many entries are in the data set and how many columns? How does R show you that? How do you do that with R? What's the code? Put a screenshot. Just work your way through this. Okay, now I'll show you what the data looks like. It looks like this. Okay, so here we have some numbers. Okay, along row 1, we have, let me zoom this in a wee bit, the years starting from 1980, going forward to 2021. And down column A, we have countries starting, as you might guess, alphabetically. So Afghanistan, Albania, Algeria, Angola, and Antigua, Argentina, Armenia, Aruba, Australia. Be quite amusing, an amusing thing to do, to memorize all of these in order. But anyway, so right, so let's pick a country. So let's just go with the first one, Afghanistan. The reason we have zeros in here is because we don't have any data for Afghanistan for these years, okay? But when we get to, say, 2002, we have 5.1. And what that means is the value of the CPI increased by 5.1%. Now, that might not mean anything to you just now, but when you've had a look into this, hopefully it will. So a little bit of research required and then a little bit of analysis in R. And that is this week's practical. Okay, I'm going to stop the recording now, see if anyone wants to ask any questions. So that was topic 4, and that is the work for this week. So I'll stop recording.